Chapter A is a review chapter of material you should have learned in previous math courses. We'll go over a handful of sections from this chapter. The first section is 8.1 on the real numbers and integer exponents. Please check the Canvas notes for supplemental material on definitions and other items you need to review. In this particular video, I will go over the highlights and a few short examples. The first thing I would like to talk about is order of operations, the acronym PEMDAS. That stands for parentheses, exponents, multiplication, division, addition, and subtraction. Remember, when we do order of operations, we will always go from left to right. Next, let's talk about set notation, union, and intersection. A union B uses a symbol that looks like a U between the two sets, and union represents what's in set A or B or both. Intersection, A intersection B uses a symbol that looks like the letter N, and this represents what's in both A and B. Next, interval notation. Interval notation we will use to describe certain answers, to represent things like domain and range, etc. To see the full table of all the possibilities of interval notation, you can check out the e-text or the textbook on your MyMathLab account online. Here's one example. If I have the area shaded from A to B, where A is a filled-in circle and B is an open circle, I would write my interval notation like so, where I would have a square bracket at A, but a round parentheses open for B. Square bracket again means I'm including the value A, but round parentheses next to B means I'm including up until B, but not the actual value of B. Next, the distributive property states if I have A, open parentheses, B plus C, close parentheses, that means A times B plus A times C. Next, the zero product rule. That states if I have two items, A times B equal to 0, that means A equals 0 or B equals 0 or both. Exponents. A to the n means I'm going to multiply A n times. For a complete list of exponent rules, again, make sure you check out the supplemental notes posted on Canvas to go over the rules. If I have two things multiplying, what do my exponents do? If I have two things dividing with the same base, what do my exponents do, etc. So please make sure you check out the supplemental notes for all the rules as a fresh reminder. And the last example I want to complete is the following. 2x to the negative 2y cubed all over 4 times x times y to the negative 8 all raised to the negative 2. So I'm going to do all the exponents rules in one problem, or just about. Alright, there's more than one way of solving this problem. There's not just one correct way, but I'm going to show you the way I like to do. So the first thing I usually do is take care of this outside exponent negative 2 by taking care of the negative first. So that negative indicates a flip of the fraction. So the denominator is going to become the numerator, and the numerator is going to become the denominator. And so all I did was take care of that outside negative, and now it becomes positive. Next, I like to simplify the inside stuff. So, 4 divided by 2, my coefficients, that's going to be 2. Then I have x to the 1 over x to the negative 2. My rule of thumb is always bring the smaller number to the bigger number. So -2 is smaller, so x to the 1 stays. X to the -2 moves, and when I move it to the other side of the fraction, it becomes positive. Next, I have y to the -8, y cubed. So y3 is going to stay. Y to the -8 is going to come down and become positive. Simplifying, I have bases that are the same, so my rule is exponents add. All right, so we've got 2 times x cubed over y to the 11. And last but not least, now I'm ready to square everything. 2 squared is 4. Now x cubed squared, I call that the power of the power rule. So that means my exponents actually multiply. So that's x to the 6 over y to the 22. And the problem is complete. Again, I want to make sure I have no negative exponents in my answer.